This video is going to show three things: reading an analog input, making a decision based upon the analog input, and using pulse width modulation. Okay. So I've got a thermistor here. It's the cold temperature just now. Down here, I've got a reading of the value that's sitting at the analog input. So just now, the value sitting there is 13, and I've got the motor stopped. The idea is that the motor goes faster the hotter it gets to keep whatever cool. Okay. So we'll start off, there it's cold, and it's stopped. Okay. Push up a wee bit. So you can see it's growing. So X is 21. So it's going down, doing the flow chart. Is X less than 20? No, it isn't. Okay. Is X less than 60? Yes, it is. So it comes down here. Input 0 goes on, waits for 0.01 seconds, goes off, and it waits for 9. So there it is. It's on, and it's off for 9, on for 1, off for 9. Okay. Small pulse, big space. Sorry, small mark, big space. Okay. If I increase the temperature a wee bit more, so that 60, it's less than 60, so I'll make it a little, make X just above 60, and we should see the pulse width modulation change. There it goes, 63. So where I was on for 1 and off for 9, now I'm on for 5 and off for 5. So I've got like 50% duty cycle. If I increase the speed a little bit more, so I'm more than 120. 106. There we go. So I'm now on for 8 and off for 2. Okay. Now it's gone up, and I'm now bigger than, well, I'm at 120. Shouldn't be on yet, but there we go. Up we go. 124. So is it less than 120? No, it isn't. So of course, the program is running around these boxes all the time. So now I've dropped it back down. So X is 40. So it comes down here. Is X less than 20? Well, no, it isn't. Is X less than 60? Yes, it is. I put 0 on. So we're back to the mark of 1 and a space of 9. Okay. The MOSFET is good for switching. There'll be very little voltage. There'll be practically no voltage drop between these two, so that all the energy is going into the motor. There should be no heat generated. Okay. MOSFET is very efficient for use in switching applications. Okay. Pulse width modulation.